Hello students. So this is a question from TIFR 2024 from electrodynamics and electromagnetic theory. And in this question you see a thin spherical shell of radius capital R has a constant surface charge density sigma. This shell is cut symmetrically into two pieces. What is the electrostatic force between the two halves? Okay, so if I just make this like suppose this is a sphere and it is cut into two halves like this, so one half will become like this, and we have to calculate the electrostatic force between these two halves. Okay, like this. Okay, now this is a spherical shell, so if I see the electric field just outside, it is sigma by 2 epsilon naught, and inside is 0. Okay, in a spherical shell. So on an average, the electric field is sigma by 2 epsilon naught. Okay, now if I consider the force will be equal to Q into E. Okay, and force per unit area, if I see, it will be equal to sigma into this electric field, sigma by 2 epsilon naught. So force per unit area will be felt as sigma square by 2 epsilon naught. This is force per unit area, but we want electrostatic force. So you see, force will be felt like, if you see here, it will be in this direction. If you see here, it will be in this direction. And then you take the resolution of vectors. So effectively, I want force in this direction or in this direction. This will be the repulsive force. So if I see the force, it will be force into area. You can just take theta and integrate also, but it is so easy to see that if I see this perpendicular force, effective area is only this much. Okay, by taking the components. So, or you can just calculate it by integration. So this will become sigma by 2 epsilon naught into this effective area is pi r square. So it will be sigma square by 2 epsilon naught into pi r square. Okay, so this is very nice question. You can just try by taking the components also, and you will get the same answer, because effectively the area will be only pi r square. Okay, thank you.